Okay, moving to our final concept of the circles unit. It begins on page 415. The title of the lesson, Solving Circle Problems, or as they put it, using circle properties to solve problems. Now, before we go any further with using circle properties to solve problems, we haven't covered all the circle concepts just yet. We have a couple more that we're going to cover today. So as you can see, I've made a circle here. Make your own circle with a protractor or what have you. Typically I do it, lay down the protractor, make one half, make the other half, and that gives me a nice precise circle, and I know exactly where the diameter and the center are if I need to know that. And I can, that's the first thing I'm going to do, is label the center of my circle. It's a 10 centimeter circle, as it usually is when you're using a protractor, the ones that we have anyways. That's a 10 centimeter circle. Now I'm going to inscribe a quadrilateral into this circle. I'm roughly copying the one that they have on the top of page 416, if that information is of any use to you. So whenever a quadrilateral is inscribed into a circle, so we have point O as the center of our circle. Of course, that's not the center of our quadrilateral, and we're going to label the quadrilateral C, D, E, F. Something very unique happens, and that is you get supplementary angles. So let's first of all define supplementary angles on the side here. Supplementary angles add up to 180 degrees. Now, supplementary, when you get a quadrilateral inscribed into a circle, angles that are supplementary are the ones that are opposite of each other. So this one and this one will add up to 180, and this F and D, C and E will add up to 180, and F and D will add up to 180. One of the very unique properties of a quadrilateral inscribed into a circle, and let's just prove it. Let's not assume, right? So that's not correct. That can't be right. Must have measured something wrong. This is a 110 degree angle in this corner, which means the one up here should be a 70. So let's just do a measurement, shall we? I'm up in the corner now, as you can see. And yep, bang on. You see the 70 there? So let's measure this one, E. This is 105, which means that this one here, this time I won't measure, 180 take away 105 is this up here is a 75 degree angle. The other thing that should happen is, my calculator vergessen, I'll go grab my calculator. So opposite angles are supplementary, and of course the sum of the angles Just as a circle is 360 degrees, the sum of the angles of this quadrilateral add up to 360. So 70 add 75 is 145. Then we have 135, add 10 is 145, and then 105. So that's, I miscounted. I'll use a calculator just to make sure I get it right. Shall we? And it adds up indeed to 360. Got a little shaky with my mental math there, didn't I? Now, just one more new concept. This one isn't complicated. Let me just make another circle. That's good. Yeah. Now, I'm going to inscribe another quadrilateral, this one based more on the center of our circle, and you'll see why I'm doing that in a second. So the main concept that you should know so far is that when a quadrilateral is inscribed into a circle, opposite angles are supplementary. They add up to 180. And the total should of course be 360. So let's inscribe this one now. Based on the middle, I want to inscribe, I just want to do an accurate drawing here. I could just use the one in the book, but you know, it's always better to do this. So we have an inscribed angle. So here you have your central angle right here. Now if we go here, here, you notice something, right? There's a circle in the middle there, isn't there? So these two angles, this angle here, this one, and then this one on the outer side, they will add up to 360. So if you know the measure of one of them, then you can simply subtract to find the measure of the other. So let's just do the measurement of the interior of this angle here. I think that's the best approach. This is a, let me get the center down and the line down. This is a 130-degree angle in here. Now, how can I find this one here? Well, a circle is 360 degrees. So we do 360 minus 30. That's 260 minus another 30 is 230 degrees. See? So these angles in the center here all together, the two of them together, because they're in the middle of the circle, add up to 360 degrees. So as soon as you know one of them, you can subtract from 360 to find the other. So that's the center of your inscribed quadrilateral. So this is a very straightforward concept. You can see it. And we'll do a few more examples where that's going to become clearer. So let's go to those examples on page 417 and they're both on 417. And then we're also going to be reaching back to previous concepts as well. We've added these two, and we're going to be reaching back to others as well, such as when it's inscribed in a semicircle, it's a 90-degree angle. The outside angle is twice the measure of the central angle when they're in the same arc of the circle. And of course there'll be situations where we'll use Pythagoras, reaching back to all those previous concepts. Now, with that, let's have a look at page 417. Let's see what they've got for us there. So, point O is the center of the circle with an inscribed quadrilateral EFGH. EFGH. And then EOG is 140 degrees, so that's EOG is 140 degrees. Determine the values of X and Y. Okay? Let's have a look at this. Well, we have a central angle of 140. This is, if we were asked to find this angle here, where the O is, we would do 360 minus 140, and we would have it. But they're not asking us to find that. They're asking us to find the inscribed angle on the outside. This is going to be double, or half, I mean. The interior is double of this. Okay, so angle F, 140 divided by 2 equals 70 degrees. Therefore, angle F equals 70 degrees. That was easy. Now we got another angle down here, angle Y. Notice that up here, or down here, we have two different quadrilaterals inscribed into this triangle. They're both based around the center. So look at this quadrilateral here. We know that one of these angles is 140 degrees. What do we know about an angle that is opposite? Angle inscribed into a circle, and the two that are opposite of each other? Supplementary angles, isn't that correct? So we're now looking for angle H, and that's going to be 180 take away 140, because supplementary angles, these are, when they're like this, they're supplementary, they add up to 180, and that is 40. Therefore, angle H, oops, I forgot to show you all my work, didn't I? That's not very helpful. Okay, now I'll go over it. So there's the central angle, and the outside angle is half of it, so 140 divided by 2, 70 degrees. Therefore, angle F is 70 degrees. And then we have two angles that are opposite each other in a quadrilateral inscribed into a circle. That's 180 minus 140 equals 40 degrees. Therefore, angle H equals 40 degrees. Inscribed angle, and of course there's the explanation and the solution, but let's look at it. A regular octagon is inscribed in a circle, and the circle has a radius of 12, so this here would be a radius going all the way from the middle to the outside. That'd be a 12. Each side of the octagon is 11.1 centimeters. What is the perimeter of the octagon? Give the answer to the nearest tenth. So each side is 11.1. What is the perimeter? So they're saying each side, 11.1. So what we can do here, we can use the triangle they've inscribed to find the length of this half, and then we'll find the length of that. I just want to check their math here for a second. Just give me, I'm not quite following their logic here. Okay, I get it now. All right, so first thing we need to do is a squared plus b squared equals c squared to find the unknown side of this triangle here. Let's start with that. So this is, up here we had example 1. Now we want example 2. A squared plus b squared equals c squared. So we don't know our short side. A squared plus 11.1 squared equals 12 squared. $123 and 12 squared is 144. I really should have done the 144 first. Some of that, so. And then we'll subtract 144 minus 123.21, 20.79. And of course we need a square, or 20.79, yeah. And of course we need a square root of that 4.56. Multiply it, so that's one side. So one side of the triangle is 4.56. Let's look back at our triangle now. So we now have the short side of this triangle is 4.56. This is a bisector. If this is coming in from the middle, then this is splitting this exactly in half. So if this is 4.56, then this is also 4.56, because this is coming up from the center of the circle. It's a perpendicular bisector. This is exactly 50-50. So 4.56 times 2. Equals 9.11 centimeters. So that's the measurement of one of those sides. Now, how many sides does an octagon have to finish off our problem? 9.11 times 8. Then it becomes relatively simple to just do that. 72.88. And they're saying 72.96, which they rounded up to 73. That's just working with the decimals a little bit differently, but we're accurate enough. Which brings us to our homework. This was not a long lesson now, was it? Brings us to our homework, which you'll find all of it on page 419. So let's write down the questions and then I'll go over them. 419, 3, 4, 5, 6, and 7. All questions on page 419. Oui, oui. Got that written down. Let's go over the questions. Could each quadrilateral be inscribed in a circle? The point is, if it can be inscribed in a circle, then these two sides have to add up to 180. the ones that are opposite. If they don't, it's not. 100 at 100 is 200. You can't do this one. 90 at 70 is 160. Nope. But there are some you can do. But the point is the opposite angles have to add up to 180 for it to be inscribed into a circle. They're going to have to be supplementary. Okay? 4. Determine each value of x and y. This is all based on the fact that opposite angles add up to 180. 105. So how can we find this one? 110. How can we find the one up here? Look over here. 115. How can you find the one up here? Clearly a 90 here because they've got the square. So then how can we find the one up there? Okay. Good. Should be. 5. Here we have a 75-degree angle on the outside, right? So that should tell you something about the central angle, shouldn't it? Double it up, right? Double it. And then use that information to find out what B is. And you can do that, I should think. So you have this, and you'll be able to work out the rest. Though I do have a bit of, well, no, I won't give you a hint. B is easy enough to figure out. I'll leave it at that. 5B, we're looking for B and A. Okay? Now, take a careful look at what's happening here. We have the 85 over here. So measure of an 85-degree measurement, and this is a 20. So we can find the one down here. We can find this one. And once we know what this one is, 180, take away 85, take away 20, we know what that one is. You know this measurement? Then think of this shape as being a quadrilateral. And then this will be supplementary to A. Supplementary, they have to add up. Once you know this, then this and this have to add up to 180. Okay, so now you know this side. Then look over here. Equality symbols. These two sides are equal. This is an isosceles. So this angle has to be equal to this angle. So whatever this angle is going to be, the main angle, the big angle is going to be, subtract from 180 and divide by 2, because this is an isosceles. These two have to be equal. B is a bit of a tricky one, but I think I laid it out well enough for you that you should be able to just, should be a low-hanging fruit at this point. You know, the easy Saskatoon in the berry patch. Point O is the center of each circle. Label each vertex. Determine each value of R and S. Here we have an inscribed angle, right? So what's angle S then going to be compared to this one? The good old doubling concept, right? So once we know what S is, what is the full thing going to be here? Remember the circle concept? It's got freezing up here. There, I'm back. I had to freeze for a bit. The full circle is going to be 360. So once you know what S is, what do you do to find R? Just subtract, right? Looking at this one, we have 100, and look at it's a quadrilateral, and these two are opposite, so they have to add up to 180. And then this becomes your inscribed angle for this central angle. So once you have this, boom, you can find this, I should hope. Yep. Now we're looking here. We're only looking for one unknown, and that's the Y up at the peak there. Well, we can't use this angle. It has to be the one that's on the outside. And then this would become the inscribed angle. Right now it's not the inscribed angle of this one, but it would be of this one. So how can we find this? It's a circle, right? It's gonna, this together with this has to add up to 360. So then we subtract, we know what this is, and then easily figure out what angle Y is. That's it for this lesson. That brings us to the mid-unit review, which will just be a brief recording